beginning a new chapter on acids and bases. This is chapter 11 of your textbook, and section 11.1 is an introduction to acids and bases. Now, this is not the first time that we've talked about acids and bases this semester. We've discussed the fact that acids are associated with hydrogen ions, and that if you look at the chemical formula of a compound and it begins with hydrogen, that's the signal that you're looking at an acid. Likewise, we've discussed bases, and you've been instructed as an introductory idea that bases are associated with hydroxide ions, and that if you look at a formula and see that it has hydroxide in it, associate that with the base. These are beginning concepts, and as you go further in a discussion of acids and bases, you'll see that these concepts can be developed to a greater degree. But at this particular point, looking at the formulas of the compounds that I've written here, HCl, HC2H3O2, H2CO3, all of them begin with hydrogen ions. We also have looked at nomenclature of acids, how to name them. There is a previous video dedicated to acid nomenclature, number 021, and you can look at that nomenclature video and be refreshed on how to name these acids: hydrochloric acid, acetic acid, and carbonic acid. Likewise, base nomenclature is associated with ionic compound nomenclature. You can review the video number 018 on ionic compound nomenclature part 1 and review nomenclature of bases: sodium hydroxide, calcium hydroxide, and ammonium hydroxide. Let's take a look at characteristics of acids and bases. We'll look at a characteristic and see how this characteristic applies to both an acid and a base, or either an acid or a base. Let's take a look at number 1. What type of ions are associated with acids and bases? We already reviewed that. Acids produce hydrogen ions in water solution, and bases are associated with producing hydroxide ions in water solution. So we can add that little aqueous right there. In terms of electrolytes, do acids and bases dissolve and dissociate in water to produce ions? The answer to that is yes. Both acids and bases are electrolytes. They will dissociate, produce ions in aqueous solution. Acids can be categorized as either strong acids, meaning they're strong electrolytes and completely dissociate in aqueous solution, or as weak acids, meaning they're weak electrolytes and only partially dissociate in aqueous solution to produce ions. The same principle applies to bases. Bases are electrolytes, and you can either have a strong base, meaning the base is a strong electrolyte, or a weak base, meaning the base is a weak electrolyte. In terms of taste, if you taste an acid, it has a sour taste. So we associate that, for instance, with orange juice or lemon juice, which has the acid citric acid in it, and that sour taste that you have when you drink orange juice or lemon juice is associated with acids. Bases, on the other hand, have a bitter taste or a chalky taste. In terms of how they feel to the touch, acids, if you have them spill onto your hand, may sting, have that stinging sensation. Bases, on the other hand, if you have a base on your skin, it will feel soapy or slippery to the touch to your skin. In terms of neutralization reactions, acids will neutralize bases. They will react with bases and undergo a neutralization reaction to produce a solution that is neither acidic nor basic. Bases, on the other hand, will neutralize or react with acids to form a solution that is neither acidic nor basic. In terms of indicators, which are compounds that produce a characteristic color in the presence of either an acidic solution or basic solution. That's what indicators are. There are two very common indicators that are associated with introductory chemistry. Those indicators are litmus indicator and phenolphthalein indicator. Litmus indicator will produce a red color in the presence of an acidic solution. On the other hand, it will undergo a color change to form a blue color or a blue solution in the presence of a basic solution. Phenolphthalein indicator, on the other hand, will have a colorless appearance, no color at all, in the presence of an acidic solution. Phenolphthalein will turn pink color in the presence of a basic solution. And the last characteristic is the pH of the solution. If a solution is an acidic solution, the pH of the solution will be less than 7. pH less than 7. If it's a basic solution, the pH will be greater than 7. And just mentioning, what if the pH is exactly 7? That means that the solution is neither acidic nor basic and is neutral.